This is the study guide for 6.2, altitudes and perpendicular bisectors. It also gives you a little review of that information right here. It tells you what an altitude looks like, it tells you what a perpendicular bisector looks like. Over here in this diagram, there's a whole lot going on. If it helps, you can redraw the picture. So they're telling you in this triangle that segment GC is congruent to segment CH. So we can mark that if we want. Now, the point of them telling you that is, point C is a midpoint. That's what you get out of that. Also, segment FE, that's this one, is congruent to segment EH, which is really hard to mark. So I'm not even going to do it. Because notice how there's another smaller segment on that segment EH. So if I put two slash marks there, you're not sure which segment it's referring to. But the idea is point E is a midpoint. So E is a midpoint and C is a midpoint. Also, they're telling you that angle FGD, that's this guy right here, is congruent to angle HGD. That's this guy right here. So we have two angles that are congruent there. Which segment is a median of triangle FGH? So here's triangle FGH. Again, if it helps you, you can redraw it. FGH. Now, where would you see a median on segment FG or triangle FGH? Well, here's a segment that touches F, which is a vertex, and it also touches C, which is a midpoint. That's your median. So that would be segment FC. Which segment is an altitude of triangle FGH? So I'm going to draw the same triangle again. And I know space is tight. You can always use a different piece of paper. Which segment would be an altitude? Well, you need a right angle, and you need to touch a vertex. So find a segment that has a right angle, like this one, but it doesn't touch a vertex. So it can't be that one. This one has a right angle. Does it touch a vertex? Yeah, it does. So even though it kind of doesn't look like it on my picture, that segment AH does both things that it needs to do. It touches a right angle and a vertex. Number 3, which segment is a perpendicular bisector of triangle FGH? So the two things that need to happen is it has to touch a midpoint, like E, and it has to have a right angle. Right? So this segment BE is the perpendicular bisector of this triangle FGH. So notice how I can mark E as the midpoint better on this diagram because I don't have that point D on there. So segment BE is the other one. Number 4. Segment BV is a median and a perpendicular bisector of triangle BST. So I'm just going to draw triangle BST. And if I need to adjust, I can, but that's where I'm starting. Now, segment BV needs to be a median. So that means B is your vertex, and V better be a midpoint. So I marked it as a midpoint. That segment right there is a median. Now, they also want it to be a perpendicular bisector. Now, this is where I could have gone wrong. But fortunately, it kind of looks like that's a right angle. So if I mark it as a right angle, it's sort of believable. This is going to be a perpendicular bisector as well because it touches that right angle. So that's a good way to do it. Now, you could also say that this is also an altitude. If it touches a midpoint and a vertex, and it has the right angle, then it's all three of those things, remember. So we've seen the diagram where it's all three plenty of times at this point. Segment KT, this is number 5, is an altitude of triangle KLM, and point T is between point L and point M. So I'm just going to draw a triangle, and if I have to adjust, I have to adjust. Here's point K, L, and M. Now I want segment KT to be an altitude, so I'm just going to draw it like this, where there's T, and you want T to be in between L and M, so that works out perfectly. It touches your vertex, and it has that right angle.